Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question 39 multiple choice extracted from 2017 November time zone 0, talking about topic 11 stuff, the spectral in terms of the spectrographical understanding using the hydrogen NMR spectrum to understand organic compounds, right? So this is a really classical spectroscopy technique that to look for organic compounds, hydrogen NMR. From the perspective, what you should notice is, first of all, this is going to be a spectrum looking for hydrogen. Several information that student must be able to know, but here comes in the testing point of the first information, and that is the number of peaks. Here you can observe from this spectrum reveals to you how many families of hydrogen. So remember here, the first information and first and foremost, the most important information is that the peak number is actually referred to the number of families of hydrogen. And what mean by the same hydrogens within the same family is that if the hydrogens are going to be having the same bonding pattern, then those hydrogens will be grouped as the same family, right? So in this case, what we observe is 1, 2, 3, 4 peaks. So what we kind of guess is that there will be going to be 4 families of hydrogen. That means 4 groups of hydrogen should be isolated from this compound if this spectrum is referred to that compound, right? So let's see the choices, right? For the choice of A, what you see is that this is a really symmetrical compound, having CH3 connected to CH2, and then single bond with an oxygen, and then CH2, CH3, right? So for this perspective, the more symmetrical the compound is, the more the hydrogens will having the same chemical environment or the same bonding pattern. So that's why in this case, at the end, you should realize that the two groups of hydrogen in the corners are within the same family, and then the middle carbon having the same family. So here only have 2 families, right? Because the bonding pattern is so symmetrical that the left side is reflecting as the right side. So that's why here we do not see 4 families but only 2 families, because the 2 sides are just kind of symmetrical. So that's why the families will be smaller than expected. Make sense? So for B, in this case, it is going to be ethanol with CH3, CH2, and O single H, right? So no doubt here going to be having the first individual family with the corner carbon, and then the next family, and then finally an independent family of the hydrogen in the hydroxyl group. So totally, it only contains 3 families, right? So 3 families do not occupy 4 peaks in the hydrogen NMR spectrum. So again, not our choice, right? For the choice C, again, a really symmetrical alkane called the propane with a CH3, CH2, and CH3 pattern, right? So from the choice of A, what you can realize is that the more symmetrical the hydrocarbon, the less families is going to be expected, because more symmetrical you are, more hydrogens will be grouped together. Similarly, for this case, the 3 carbons on the 2H will be grouped as the same family because the bonding pattern is the same, and the middle 2 will be the same family. So all entirely here only contains 2 families again. So that's why not our choice. And finally for D, if you look up in the choice of D, this is going to be an asymmetrical carbon. Thanks to the hydroxyl group, point to the H, right? So if I point this out, right, then you realize that the H carbon contains 3 hydrogens to be same family, 2 in the individual family, another 2 in the individual family, and finally 1 at the corners bonded to the hydroxyl group as an independent family. So all together 4 groups, so 4 families. So 4 families, then now we'll be referring to 4 peaks that we can observe in the hydrogen NMR spectrum in this spectroscopic technique of analysis of this organic compound. So that's why obviously the choice that matching 4 peaks is with 4 families of hydrogen, and that is the choice D.